Namaskar, hello and a very warm welcome to CIET NCERT's live phone in interactive program. मैं हूं तन्वी खुराना। फिजिक्स के आज के इस प्रोग्राम में आप सभी का एक बार फिर से स्वागत करती हूँ। 12th क्लास के सभी बच्चे हमारे साथ जुड़ सकते हैं और जैसा कि आप सभी जानते हैं कि एग्ज़ाम्स आने वाले हैं, आप सब पढ़ाई कर रहे हैं, तो आज का हमारा टॉपिक भी उसी पर बेस्ड है। हमारा टॉपिक है गेटिंग रेडी फॉर CBSE एग्जामिनेशन, जिसकी तैयारी आप इस वक्त कर रहे हैं। हम आपको बताना चाहेंगे, अगर आपके पास कोई सवाल है, कोई ऐसा सवाल है जो आपसे सॉल्व नहीं हो रहा, फिज़िक्स से जुड़ा हुआ कुछ भी टॉपिक है जो आप समझ नहीं पा रहे, कुछ भी डाउट है, तो आप हमसे जुड़िए, बातचीत कीजिए, पूछिए अपने सवाल हमसे। आप चाहे तो हमें फ़ोन कर सकते हैं, नंबर है 8800440559। अगर आप चाहें तो हमें ईमेल कीजिए, ईमेल आईडी है dth.class12@ciet.nic.in। Apart from this, you're watching us on PME Vidya channel number 12 and also on our YouTube channel that is NCERT Official. उसके लाइव चैट बॉक्स में भी आप अपने सवाल लिखकर हम तक पहुंचा सकते हैं, तो आपके सवालों का हम इंतज़ार करेंगे। सबसे पहले हम आपका परिचय करवाना चाहेंगे हमारे आज के साइन लैंग्वेज इंटरप्रेटर्स से। अभी आप अपनी स्क्रीन पर देख सकते हैं, हमारे साथ हैं राशि, और राशि के साथ अतुल भी हैं। अतुल भी हमारे साथ इस कार्यक्रम के पूरे दौरान जुड़े रहेंगे और साइन लैंग्वेज में हम जो भी बातचीत करेंगे उसे आप तक पहुंचाएंगे ताकि आपको कोई परेशानी ना हो। और इससे पहले कि मैं आपको हमारी गेस्ट से इंट्रोड्यूस करवाऊँ, मैं आपको एक इन्फॉर्मेशन ज़रूर देना चाहूँगी। जैसा कि मैंने अभी बताया कि एग्ज़ाम्स आने वाले हैं, आप सब पढ़ाई कर रहे हो, तो आप सभी जानते हो परीक्षा पे चर्चा एक कार्यक्रम है और वो हमारे माननीय प्रधानमंत्री श्री नरेंद्र मोदी जी ने शुरू किया था। उन्होंने उनकी पहल की थी, जिसका आयोजन हर वर्ष किया जाता है और इस वर्ष इसका 9वां संस्करण आयोजित किया जा रहा है, जिसका उद्देश्य आनंदपूर्ण अध्ययन को बढ़ावा देना है और साथ ही साथ परीक्षाओं को तनाव मुक्त बनाना है। अगर आप इसके बारे में और जानकारी जानना चाहते हैं तो एक वेबसाइट हम आपको बताना चाहेंगे, innovateindia1.mygov.in। आप स्क्रीन पर भी इस वेबसाइट को देख सकते हैं। आप इस पर जाकर परीक्षा पे चर्चा जो कार्यक्रम है उसके बारे में और ज़्यादा जान सकते हैं। तो आइए परीक्षा उत्सव को जीवन के उत्सव में हम बदले साथ मिलकर। चलिए हम इस जानकारी के साथ आपको हम अपनी आज की मेहमान से इंट्रोड्यूस करवाना चाहेंगे। हमारे साथ हैं मिस अनुराधा माथुर। स्वागत है मैम आपका।
थैंक यू
मैम हमारे साथ जुड़ने के लिए। मैम हैं PGT इन फिज़िक्स। मैम हैं रिटायर्ड हेड ऑफ द डिपार्टमेंट ऑफ फिज़िक्स फ्रॉम मॉडर्न स्कूल वसंत विहार न्यू दिल्ली। तो चलिए शुरू करते हैं। हम मैम से पूछना चाहेंगे, क्योंकि हमारा टॉपिक ही यही है गेटिंग रेडी फॉर CBSE एग्जामिनेशन। मैम बताना चाहेंगे बच्चे कैसे तैयारी कर सकते हैं एग्ज़ाम के लिए?
अब हम कुछ आपको सजेशंस देंगे एंड कुछ चीज़ें हैं जो बहुत ही असेंशियल होती हैं, उनको आप करेंगे तो आपके लिए ये काम बहुत ही आसान हो जाएगा और आपको पढ़ने में भी मज़ा आएगा। जैसा कि अभी बताया आपको कि परीक्षा पे चर्चा में यही उद्देश्य है कि आपको अच्छे से खुशी खुशी पढ़ाई करनी है, लेकिन एट द एंड ऑफ द डे आपको नंबर ज़रूर चाहिए। तो आप फिर देख लेते हैं क्या करना ज़रूरी है।
बिल्कुल। तो मैम प्रिपरेशन स्टार्ट कहाँ से करनी चाहिए?
अच्छा, प्रिपरेशन स्टार्ट करने के लिए सबसे पहले हमें देखना है कि CBSE हमें क्या चाहता है। तो जिसके लिए हम देखेंगे पहले तो थियरी पेपर, वो लेआउट समझना बहुत ज़्यादा ज़रूरी है और ये आपको एकदम अपने जहन में ले लेना है कि ये क्या चीज़ है, कैसे हो रहा है। तो 33 क्वेश्चंस हैं, उससे आपको डरना नहीं है। ये कितने सेक्शंस हैं और हर एक में क्या क्या है और क्या चीज़ कंपलसरी है और कैसे जानी है, ये भी आपको ध्यान में रखना है। तो सेक्शन A में 16 सवाल हैं एंड दीज आर 12 MCQs एंड 4 रीज़न असर्शन क्वेश्चंस और 1 मार्क ईच। और जिस तरह आप इसको स्टडी करेंगे तो ये आपको एकदम ठीक से पता होना चाहिए कि हमको 2 मार्कर्स कहाँ हैं, 3 मार्कर्स किस तरह से देखने। केस बेस्ड स्टडी क्वेश्चंस हैं और 2 क्वेश्चंस हैं उसके जो कि कंपलसरी हैं और जो सेक्शन है उसमें 3 सवाल हैं और कैसे, और क्या इसमें आपको चॉइसेस मिलती हैं? ओवरऑल चॉइस बिल्कुल नहीं है, और इंटरनल चॉइस ज़रूर मिलेगी आपको सेक्शन बी, सी और ई में केवल। तो स्टडी के सैम्पल पेपर को देखना बहुत ज़्यादा ज़रूरी है। उसमें मार्किंग स्कीम के साथ सैम्पल पेपर्स दिए होते हैं। इसका मेन चीज़ जो आपको मदद करेगा वो ये देखना है कि क्या क्या उसमें हमको जवाब देने की ज़रूरत है, किस तरह से प्रिपेयर करें, कहीं हम कुछ चीज़ मिस ना कर जाए, और उसको करने के लिए क्या आसान होगा। सो अभी हम एग्ज़ाम्पल के तौर पे सिर्फ ऑप्टिक्स पे काम करेंगे, सिर्फ ऑप्टिक्स के क्वेश्चंस लेंगे, क्योंकि फिर हम जितना कम में देखते हैं उसको फिर हम थोड़ा ठीक से समझ सकेंगे। समय क्योंकि कम है तो हम लोग इसको उदाहरण के तरह से ले रहे हैं। सो एग्जाम्पल में लुकिंग ओनली फॉर ऑप्टिक्स क्वेश्चंस। अब आप देखेंगे कि सैम्पल पेपर जो अभी रिलीज़ हुआ है, अभी उनकी वेबसाइट पे है CBSE academic.in पे, उसमें ये सवाल है और जिसका ये बहुत ही खूबसूरत डायग्राम है, लेकिन अगर आपने इसको ठीक से ध्यान से नहीं देखा तो ये फिर नहीं होने वाला। तो टोटल इंटरनल रिफ्लेक्शन का सवाल है। आगे देखते हैं रीजन असर्शन का क्वेश्चन भी, ये भी आपका रे ऑप्टिक्स से ही है, और वेव ऑप्टिक्स पे उन्होंने सवाल पूछा है रीजन असर्शन का फिर, और उसका जवाब भी उसमें दिया हुआ है। तो ये आप खुद देख करके भी पता कर लेंगे कि ये जवाब इसका है, ऐसे मैच करके। और सेक्शन बी में कोई भी ऑप्टिक्स का सवाल नहीं है। अब हुआ कि सेक्शन बी में नहीं है लेकिन सेक्शन सी में है, जो कि 3 मार्क्स के क्वेश्चंस हैं। उसमें एक ड्राइंग का क्वेश्चन, उसके साथ में लगा हुआ न्यूमेरिकल, और ये सारा कुछ है। तो इस तरह से उसकी मार्किंग स्कीम दी जाती है। आप देख सकते हैं रेड कलर में उसमें मार्क्स हैं। पहला फॉर्मूला लिखने का 1 मार्क, उसके बाद पूरा कैलकुलेशन का 1 मार्क, और पूरे डायग्राम का 1 मार्क है। और इसी तरह एक और सवाल है रे ऑप्टिक्स का, आपने अभी देखा। वेव ऑप्टिक्स का ये सवाल आप देखिए, जिसमें ये हाइजेंस प्रिंसिपल का पूछा गया है। इसको बनाना है आपको और वेरीफाई भी करना है, इसका प्रूफ देना है। अब आप ये देखते जाइए कि इसमें आपको कितना सब कुछ आंसर करना है और क्या समय है। क्वेश्चन डी, सेक्शन डी में क्वेश्चन नहीं है रे ऑप्टिक्स ना वेव ऑप्टिक्स के ऊपर, और सेक्शन ई में इसमें 2 सवाल हैं। और इसका मार्किंग स्कीम को स्टडी करना बहुत ज़रूरी है, क्योंकि ये एज आई टोल्ड यू जस्ट नाउ, यू नीड टू सी कि कैसे बनाना है। एक मार्क है इस डायग्राम के लिए, और ये पूरा डेरिवेशन फिर बाकी का, और क्या होता है मिनिमम डिविएशन कंडीशन में। सो दिस विल हेल्प यू इन अ वेरी वेरी बिग वे. You have to give some time for it. And the important thing to note about this sample paper is another very useful thing, that it is 18 marks were allotted for this, and the sample paper has covered these, but all sections do not carry questions on optics. So you do not leave out any part of the syllabus. Many children start to do selective study. That is not the nice way of doing things. So अब आपको देखना क्या क्या है, CBSE academic.nic.in बोर्ड की वेबसाइट. अगर आप CBSE से नहीं जुड़े हैं तो आप अपने बोर्ड की देख सकते हैं. NCERT की टेक्स्ट बुक आप बिल्कुल अपने साथ रखिए. अब ये स्टडी का कोर्स स्ट्रक्चर देखना ज़रूरी है. ये भी आपको वेबसाइट से मिल जाएगा, और इसका पूरा लेआउट है कि हर एक यूनिट के कितने मार्क्स हैं. इसके साथ साथ बोर्ड आपको सिलेबस का ब्रॉड वो भी देता है व्यू. जैसे रे ऑप्टिक्स में ये सारी पूरी लिस्ट है. अब इस जो पूरी लिस्ट है इसको आप खोल करके इस तरह से लिखिए 1 2 3 4 करके, एक तरह का वर्टिकल लिस्ट बनाइए. इसको पॉइंट वाइज लिखने का फ़ायदा एक ये है कि as soon as you finish with your revision you can put a tick mark there. So that will give you a lot more confidence of being able to be ready for the exam. Optical instruments, check out what details are required. Astronomical telescopes, reflecting as well as refracting type. Simple and compound microscope, you have to look for all the details. So magnifying power दोनों की चाहिए आपको. Wave optics इसी तरह से आपको syllabus book में मिलेगा, उसकी भी आपने list बना ली और इस तरह आप रख लीजिए. इसके अलावा there is something that is given in the experiments list. Many of you do not take practicals very seriously, but this is very important. Read through all the experiments, all the things that you have to understand over there. That means when you are saying, say, find the value of V for different values of U. Now, a numerical can come on this. So, if you have read this and you've done the experiment, then it becomes a lot more easier. So, go over the entire list of experiments that are to be done by you at the end of the exam. You have given your practical exams by now, you should have finished it. So, you would have a fairly good idea. But yes,
ma'am, why do children need to study experiments?
You see, there is a big connect between the theory that you learn and the practicals. So when you actually see the rays of light focusing at a point, giving you an image, you are seeing an image formed in different location, that makes you understand why that particular expression or formula was given. And say for example, in the case of a prism, the main idea there is to look for the angle of minimum deviation. So if you are not doing the experiment, learning about minimum deviation would mean what? What is this minimum deviation? Which deviation are we talking about? So the practicals clarifies everything that you learn in your theory, and therefore it is very, very important that you do so.
Okay, ma'am, one more thing. When we are going through the examination preparation, marking scheme कैसे बच्चों को help करती है?
Marking scheme details देती है कि किस चीज़ को लिखने के बाद आपको कितने नंबर मिलेंगे.
ठीक है.
तो अगर आपने उसको ठीक से स्टडी किया, मान लीजिए एक पर्टिकुलर डायग्राम के लिए 1 मार्क, तो इसका मतलब आपको वो 1 मार्क लेने के लिए वो एक्यूरेट डायग्राम बनाना है, जिसकी तैयारी के लिए आपको अपने आप से पहले से उसको अच्छे से बनाना आना चाहिए. बिकॉज आप वहाँ पर बैठ करके वो डायग्राम बिल्कुल नहीं बना सकते. उसको कई बार आप जब प्रैक्टिस करेंगे तभी वो डायग्राम अच्छे से बनेगा, एंड यू विल गेट दोज that 1 mark, which is so simple because it is a pre-learned question. Supposing there is a new question where you have to think. In that case, you will need time to spend on that. So, to save time and so many things, this marking scheme helps you. Supposing there is a derivation. So, you learn how to do the derivation. And that is why this is absolutely necessary that you learn how to go through the marking scheme.
Okay. And like your PPT says, how can we score better in optics?
Yes. So, I am going to just take up optics right now because the syllabus is wide, but as I said, we will concentrate on that. So, tips for this is mastering the sign convention. Then visual representation, as I just told you, Tanvi, that you need to practice drawing accurate diagrams. For this, you have to know that how big this notebook or the book there you will get your answer script, answer sheet. That answer sheet, the size you already know. So, you can plan, okay, I should have a line of this many centimeters. Thereafter, I should place my lens in this particular position, and you know, something that will allow you to understand how to make a diagram for compound microscope in the least possible time. So, practicing this becomes very, very important. Then conceptual derivations, all the derivations that are supposed to be done, you try and do them logically, understanding each step. Because over there, if you write one step and by memory you write something else, it does not connect, you unnecessarily lose the marks there. So, and use your NCERT resources. There are plenty of them. In fact, there is on Diksha you might find Draw With Me. It is a animation which allows you to draw good diagrams for compound microscope and telescopes and all that. So, let us focus on these 4: sign convention, and magnification, Huygens Principle and why we need it, diffraction, interference and explanation of fringes. This is sometimes that these 4 topics give a little bit of problem in understanding, and you need to revisit this to understand it fully. By revisit, it means that it does not matter even if you have to read it again and then think about it and then again come back and read it, because that will clarify the small new words that you are learning at this time. When you say convention, means that everybody is to use it that way, so that it is uniform for everyone. And what is the meaning of this sign? Sign means that plus and minus. So, you allocate with a number a plus and minus in order to indicate what it means. Say for example, when you talk about some object which is placed in front of a concave mirror, and you by convention are taking the rays hitting the concave mirror coming from the left hand side, and therefore, if you use the Cartesian coordinate system, you will find that the pole of the mirror is corresponding to 0, 0, and all distances for a concave mirror would be, say, the focal length and the center of curvature, they would lie on the negative side. This is just to make you understand that if you were working with a convex mirror, this value would have been different. The focus and the center of curvature are both going to be lying on the positive side. So, if you are able to see from the sign of a particular value that okay, this is plus so much, that means this value is lying on the right hand side of the pole. So, that is what the sign convention really relates to. So, spherical mirrors, like for example, all the measurements are done from the mirror's pole, and if it is concave, then it is negative, as I just said, and convex, it is going to be positive. Focuses are by 2. So, the focal length, the relationship you have there, and you have linear magnification, which is the ratio of size of image to the size of object. It has a minus sign over there, and it is very easy to understand why minus sign would have come, because if your object is on the negative side, and if your image is also formed on the negative side, then this particular value will show negative value. So, this will be a real image, because it is going to be shown that way. Now, in spherical surfaces as well, notice this is again you are following the laws of refraction here, but using sign convention in order to talk about u and v, and this value comes out, this relationship comes out from there. So, refraction by a lens, and for a thin lens if you see, then there are 2 refracting surfaces, one from where the ray enters the lens and the other from where the ray emits or emerges from the lens. So, then you see this di1, that is the distance from the location D up to the point where the image was formed by the first surface. Now, that is going to act as the object for the second surface, because the ray is coming along that. So, it is not really existent there for the second surface, but it is a virtual object. So, and because it is coming from the other side, it has a negative sign. The sign convention allows you to set up this equation and is able to give you the value for the thin lens formula then. So, when you are doing the derivation, sometimes you say that we have already used the sign convention. Now, what is the need to do it when we are solving numericals or doing other problems? Yet again, if you see that the sign convention was used in that particular specific case. However, you did generate a generalized formula. So, every time you use it in a numerical, you will have to again reapply the sign convention. I am going to do some 2 simple numericals, they are from the book, but quite interesting. Double convex lens, are to be manufactured from a glass of refractive index 1.55 with both faces of the lenses having the same radius of curvature. What is the radius of curvature required if the focal length is desired to be 20 centimeters? Now you are talking about a double convex lens. Focal length for it is going to be positive because it converges the rays. So, the rays are coming from the left hand side, it will converge on the right hand side. So, f, if you notice, the refractive index 1.55 in the red box, f is plus 20 centimeter. The plus is there because of the sign convention. Then you use the formula 1 upon f equal to refractive index of the material of the lens divided by the refractive index of what is outside the lens minus 1 and 1 upon R1 minus 1 upon R2. Now, these values R1 and R2 are to be the same because it says they should both have the same radius of curvature. So, when you apply it over there, notice the sign convention, there is a minus sign over there. Now, R1 is going to be positive because it is curved in a way. So, its value for the radius of curvature is going to lie on the positive side, and R2 is going to be the other surface, and for which the radius of curvature will be measured in the negative side. So, there is a minus over there, and then you get this expression. You find the value for R and it comes out to be 22 centimeters. You would not have got this if you had not used the sign convention, because then you would fumble as to what to do with it. If R1 and R2 are the same values, then 1 upon R minus 1 upon R is 0. Where do you get from there? So, this is not a mathematical equation, it is a physics equation talking about a physical aspect of a particular situation, and that is why you need to put the sign convention again. Now, let us look at another example. This is an object of size 3 centimeters is placed 14 centimeters in front of a concave lens of focal length 21 centimeters. Describe the image produced by the lens. Notice that u is minus 14, f is minus 21 and v is equal coming out to be minus 8.4. So, the magnification is minus 8.4 divided by minus 14, and that value comes out to be plus 0.6. Now, notice this plus 0.6 centimeters is above the 0 line, and therefore, x dash line passing through 0, and this is going to be your image in the vertical direction, and this is going to be a virtual image because it is positive. So, the sign convention gives you a lot more than just a negative and a positive value. So, that is how you look at it. Now, the other phobia is the Huygens principle. Now, it is an intuitive model to visualize and predict the propagation and its interaction with materials. What does that really mean? If it is a model and you are thinking, okay, it is just explaining something, so is it really there or not there? Now, Huygens construction talks about how the wave moves from one source to the ones that is outside. It says that every point on a wave front, it describes a wave front. Wave front is meaning that there is some kind of a spherical surface or some kind of a curved surface where there are infinite number of tiny points which replicate the source and send out wavelets which are the same as what the source is sending. Same frequency, same value for wavelength in a particular medium, and that is what it is. And these secondary spherical tiny points are called secondary sources, and they lie on a wavefront. The forward tangent of these wavelets forms the new wavefront. So, it is like wavefront moving ahead. What is the distance between consecutive wavefronts? 1 lambda. But lambda is so small, that means these wavefronts must be nearly overlapping. So, what are we doing over here? This is required because if you look at it microscopically and understand certain phenomena that occur in nature which cannot be explained by any other means. And that is why this geometric construction becomes very, very important. So, let us see if this model, but we need it because it also tells you how the wave moves. What is wavefront? Locus of all the points which oscillate in the same phase. Now, this idea of phase, what is phase? Now, these are some of the things which are tricky, because if you leave any one of these words out in your understanding, they will just multiply. The next thing will not be understood, the very next after that cannot be understood. So, you must understand what it means. Locus means a line joining a certain ruled set of points. What is the rule here? They should be all oscillating in the same phase. Why will they be all oscillating in the same phase? Because the wave is moving out, it is propagating. So, if it is moving as a sine wave, the sine is being repeated, the wave is being repeated all the time. So, there is a crest and a trough, as you studied in your class 9, and followed by another crest and a trough. So, the center of the crest and the center of the successive crest, that is a wavelength apart, and that is going to be vibrating in the same phase. That means, in the same direction of vibration and at the same distance from the mean position. So, this part of the phase and path, supposing you say that what will be the phase between two particles which are 4 wavelengths apart. It is a very small value, but 4 wavelengths, same phase. Why? Because they have covered the multiples of the wavelength. So, distance and phase are connected by this Huygens formula and Huygens principle, and that is why it becomes very relevant and important. How many types of wavefronts can you imagine? Spherical one starting from a central point, a point source. Plane wavefront, very far away from a point source, the wavefronts will appear almost parallel to each other, and that becomes a plane wavefront. Cylindrical wavefront would be on account of a system which is, say, having a more length, say like a big tall source of light, that will have a cylindrical wavefront. So, important about this is secondary sources, wavelets and how they move. New wavefront is to be taken only in the direction of the wave. That means it is my choice. If this is the source and the waves are going this way, I am considering all my wavefronts are for this direction. If this is the source and I am considering the wave moving in this direction, all along here I am going to be considering the new wavefronts. I will forget about what is happening to the other tangents drawn to all the other wavelets that may be there. So, you get this important thing. This is the feature about this model. Then successive wavefronts are a wavelength apart, that we have just said, and the rays that describe the direction in which the wave is moving is perpendicular to the wavefront at any location. Okay? That makes things a lot easier to understand. Now, some wave phenomena are explained only on the basis of Huygens principle, like diffraction. Now, what is this diffraction of light? It is basically bending of light or spreading of light. And when does that happen? Whenever light encounters any obstacle. Now, over here, this is an obstacle, I am an obstacle, this is an obstacle, so many obstacles, Tanvi is an obstacle. So, whenever light strikes her or strikes any object, it is going to bend, and not the way it refracts, because these are all opaque objects we are considering right here, and it is going to spread. Now, if there is a small opening, you should expect the shadow to have a absolute circular shadow, but that does not happen. It is a spread. So, this spread is taking place because light is traveling as a wave. But why don't we observe this all the time? We see a very nice shadow of ourselves in the room. Why doesn't that happen? Because the size of the obstacle or the aperture, which is the opening, must be comparable to the wavelength of light. Now, if the wavelength of light is so small that most of the objects that we have around us are just not comparable to that, and that is why we don't see it. But that means, are we never going to see this? Yes, you will be able to see. Let us see how. Interference is another phenomena, which means interference of waves. From two sources, waves are affecting the same medium, that you have learnt in your class 11 also. And what is happening there? Because of the overlap, some intensity patterns are formed. Some places are getting more intensity, some are getting less. In terms of light sources, this would mean that some are going to become brighter and some are going to become darker. And in fact, it is so amazing that you actually get light and dark fringes. That means section is bright, then the adjacent section is dark, no light there, and another section after that is bright. So, it is like fringes, fringe like finger there, nothing, finger there, nothing, finger there, nothing, like that. So, sources, and then now for sustained interference, for you to be able to see it, new words are coming up. What are they? Sources must be coherent, sources must be close to each other, and they should be nearly point sources. Then the wave amplitude should be nearly equal or distinct for distinct fringes. Wave should be monochromatic. Monochromatic means single wavelength, which is not the case usually. But it does not mean that this interference pattern does not exist for a composite wave. It does. But at the same time, to see sustained, sustained means from where you can see for a long time and you can take measurements, because it is not like it is changing and overlapping and there is no way to see it. Sustained is that word. Now, why am I expressing these words so much? Because if you do not pay attention to the words that are there, you will land up with a little bit more difficulty. Because if you do not understand what coherent sources is, you will expect all sources to give you interference, but that does not happen. So, if two sources are emitting waves of the same frequencies, same or nearly the same amplitude, and zero or constant phase difference. Now, notice we have not talked about the wavelength, because wavelength will change depending upon the medium in which that wave is traveling. So, frequency is the property of the source. So, a red light will be emitted by a red light source, and the medium is not going to change it to blue light, right. So, same or nearly the same amplitude. It should not be like this, that one source is giving very bright light and the other one is not. So, again that will be different. Zero phase difference, that means either it should be emitting in the same phase or with constant phase difference. Now, same phase is not possible from two different sources. So, a wavefront can be selected on which any two sections of the wavefront can be taken, from where you have the secondary sources. Now, these secondary sources are going to then give you interference pattern. So, if the conditions for sustained interference becomes source of light should be monochromatic, waves should be of the same frequency, direction of waves should also be the same, the amplitudes of both should be almost the same or should be the same, you can take it as that. Can we observe this effect? Of course, diffraction and interference and measurable values can be seen. How do we do that? You have the double slit experiment. Now, this experiment is important because it shows you, as you can see, there is a plane wavefront striking a sheet which has just one source, one single opening. The waves from there are striking another sheet which has two openings. So, if these two are very close, the two openings are close, then there is a chance that they are struck by the same wavefront. And if that is so, then you have your coherent sources. So, on the other side, on the extreme side of that, you have a double slit pattern shown over there. Those are the fringes that I talked about, bright and dark, and the reason why you are getting bright and dark is shown by the diagram on the other side. Now, this diagram you cannot draw on your own unless you have practiced. So, you need to practice this, keep the same value for radius and make few of these lines instead of making so many, and you will be able to see for yourself that wherever the waves are hitting or striking in the same phase, you are going to get higher amplitude and maxima, as they call it, and where the lineup is such that the waves meet a point in opposite phase, then they cancel the effect of each other, and then there will be dark point, or it will be a minima. So, here you have this very important diagram for constructive interference. Your path difference should be a multiple, integral multiple of the wavelength. Path difference here is shown by delta, and if this happens to be odd multiple of half wavelength, that means you are making sure that it is out of phase, then you get a minima. So, at any location on the viewing screen, what is the viewing screen? The waves are there, they are interacting, but if you want to see those fringes, you have to have them blocked by something. So, you put a screen on which they all land, and that is the viewing screen. And what is a fringe width now? Another word that comes in. Fringe width is basically the distance between two consecutive bright or dark fringes that you get. And for constructive interference, as we have just said, this delta value is m lambda, and for destructive it is odd multiple of lambda by 2. So, you can get questions on fringe width, and it depends upon the wavelength. If it is green light, red light, white light, supposing. So, green light has a smaller wavelength, so the fringe width is going to be smaller. Distance a viewing screen is capital D. If that is large, you will see more, but you cannot make it very large. You cannot make it more than about a meter and a half. Why? Because the intensity of light would have fallen. So, for you to be able to see even in a dark room with a telescope, you will still require this distance not to be very, very large. And the separation between the double slit, that is the small d, if that is small, the fringe width becomes bigger. Again, you can reason that out and logically interpret it. Diffraction fringes, what do they look like? Now, diffraction is a very interesting phenomenon. As we have just said that it is from bending at points or passing through little orifices and the spreading of light. Why does that happen? A single wavefront has so many different secondary wavelets. Now, these secondary wavelets are going to send out waves again similar to the source. So, that is going to interact, and that overlap is going to again cause interference. That means there will be bright and dark spots again, but not the same way as in the Young's double slit experiment. Here the path difference for a dark fringe should be a multiple of lambda. Let us see how is that happening, and the double slit pattern will be equally spaced bright and dark, and in a single slit pattern it is going to look a little different. The central one, which is called the central maxima, is going to be not only fatter than the others, it is also going to be brighter. So, let us see, this is the comparison of both these. So, single slit pattern and double slit pattern, they are going to look very different, and your questions in your paper may demand why this is happening and explain why this is happening, and able to draw or give you a difference between the two, all that is also going to be there. So, now let us see what all we have to do. Finally, you have to work hard. You will say there is no time, but if you plan, you will be able to do it. As I told you, have your list and plan it properly and then do. Write and learn. What is the meaning of write and learn? Meaning that you don't open a book and say, okay, I am doing physics, I am doing this particular thing. That doesn't work. Why? Because you know what you have to do. Now you take a fresh piece of paper and shut the book and tell yourself, what am I doing? And then you write that answer. If you do not write and learn, how will you answer where the demand is through only writing? Nobody is going to ask you any question there in the exam. They'll say, here's the paper, please write the answers. And that is why most children are not able to write there. Because though they know their answers, though they have understood everything, they are yet not able to score because they have not written it. Okay. You have to write an answer. So your vocabulary has to be right, your formation of sentences have to be right, your assumptions have to be right, everything should be written. So you write and learn. I know it means a lot of work, but just do it. Draw all the diagrams properly as you would do in the exam. Not like this, you pick up a pen and say, हाँ, this is how it's going. ये बना दिया, oh ये line ऐसे गई, ऐसे नहीं कुछ होता. You take proper measurements and say, okay, this is the width of my answer sheet, and this is the height, this is the page. Okay, now here is where I will draw this. And if I keep for compound microscope, if I put my objective lens at the center, where are you going to put your eyepiece? So you will never be able to do it. It doesn't happen on the last day or doesn't happen in the exam. So you should do this much before that. A prism and how the rays move through the prism, please draw. People cannot draw normals in the final exam. Why? Because they don't know. They understand it, a normal has to come, but then they are nervous also. So they will not be able to see that the surface will have a normal which is perpendicular to the surface. So that perpendicular has to be drawn with a scale, and it should be normal or perpendicular to the surface. So you have to consider how you will draw that. Because if you have not done that, it will not happen, just not happen. And to manage time, have a timetable, and you have to follow that. Timetable meaning what? I will get up at this time, this is my chemistry time, this and this unit I will revise here, this is what I have already seen, this is the syllabus for that section. Okay, have I covered this? What are my difficulties which are still coming up? How do I reach out and get the answers for that or solution for that? Either your teacher, or if you are using the internet, please make sure that you go to the right side. There is enough rubbish on the internet. It is very sad, but people think that just because they can talk in a fun way, they can make a video. And what are they telling you? You're wasting your time, 30 minutes you wasted. Instead of that, go directly to the right source and then get your answers from there. So, timetable and follow it. It's not like this, oh, today we gadbad ho raha, tomorrow se karenge. There's nothing like that. Make a lineup backwards. 17th the exams are starting, your lineup should end by 12th. You say there's very little time. Sure, but you've already revised for your pre-board. You are already ready with that. Now is the time to try and fill the gaps in which you will do it better and better. Now is not the time to do new things. Now is the time to clarify anything missing. Clarify that, plus make lots and lots of written work and check it out yourself. Check your written work yourself. That means if you've written a certain assumption, okay, this is how, this is a wavefront, supposing you write Huygens Principle itself, then you write every point on this. You write first that it is a model.
Right.
Then you write what it is. Then you check out on it and see where you've missed. Make your own correction. You will do a fabulous job because you are the best judge. And so, being truthful, any conceptual lag will multiply. So, just be truthful and be strict. No, I have done this wrong. Say that to yourself and it will become all right. Fix time for study, fix time to eat, that you can tell your parents or whoever is helping you with your food that this is the time. And no eating at night. People think that, oh, I have been studying, so I will eat at 2 o'clock. No. Don't trouble anybody like that. You eat at the right time with your family and the food they give you, not what you want to eat. You are ordering pizzas, you are ordering all your Blinkit is running all over the place. Why? Why are you being so unnatural? You are going to go for the examination at a particular time, isn't it? And before that you would have had time to eat, which you should, because otherwise your glucose level will go down and maybe your performance will also. So you eat at the right time, you've slept properly at night, and then you go ahead with your day. You'll see it works wonders.
So here, ma'am, I want to ask something.
Yeah.
Not all children are focused. Just the way you're saying that make a schedule, eat at the same time, exercise or study at the same time. But the child who has not done it from the very beginning, now when the exam is approaching, if they'll start today, will that even work?
It will work because your rhythm will set in.
Okay.
Your rhythm will set in. If nobody starts yoga by planning for yoga करेंगे अभी फिर करेंगे, आज शुरू है, आज breathing exercise शुरू है, so आज से शुरू है. There is nothing like this कि अब कल करेंगे, time ही नहीं है उस सब करने का. So please work on yourself, be kind to yourself, very very kind. Everything has to come from here, from you, and you have the intelligence, you have the willpower, which you must be feeling proud of. You're soon going to be ready to vote, so I think it's time to govern everything around you, and that should work. Try it. There's no harm trying it.
Absolutely. And just like you said that just reading the book is not enough.
Not at all. It just doesn't pay. It's not a story book and it's not a picture book.
So physics is not English.
No, it is not.
Is it maths? You have to keep your pen and paper ready all the time.
Absolutely. Draw it. I cannot tell you at this stage that you teach somebody. But if you teach somebody, your vocabulary improves, your sentences become short, and you are more to the point. But now I can't tell you that, because if you decide I'll go and teach my friend, then you will be talking more than you would be teaching or learning. So please stay at home, work on yourself, work on your schedule, and do a good job. And I know I have seen many people work this out even when it is not say 2 months before the exam. You still can do it. You can.
I'm sure you have now given the confidence to our children. They will do it. They will try their level best. Sure. And thank you so much, ma'am, for being with us and for giving such lovely tips, because these are what this is what required at the last moment.
Yeah.
Because if you start studying from the very beginning,
it doesn't happen.
It doesn't happen. So tips are
what they've done pre-board.
They have.
Most schools have done 2 pre-boards.
Yes.
So now they know exactly where I'm going wrong. And instead of getting nervous about it and saying, oh no, I don't know what to do, doesn't matter. See what you can. So that is more important. What you can is going to bear fruit, rather than telling yourself, I can't. That's not going to work.
Thank you so much, ma'am, for clarifying the doubts of our children. They are going to pass with flying colors, I am sure.
I hope so. I hope so.
Fingers crossed.
All the
for
very
sure.
best.
Thank you so much, ma'am. Thank you for being with us today. It was wonderful having you. It was a privilege to talk to you. Thank you.
My pleasure. My pleasure. I love it.
Thank you. So thank you to each and every viewer, and this particular program was not related to any particular topic of physics, but because you're preparing for your exam, your CBSE examination, you needed some tips and ma'am helped you out with it. So I really hope that these tips are going to be helpful in your examination, and for any doubts, any queries, you can always go to your teacher and you can always connect with us as well. Thank you so much once again for being with us, and thank you to our sign language interpreters Rashi and Atul for being with us throughout the program, and I really hope that the sign language interpretation helped you in a lot, in a much bigger way than I can think of. So with this, we are wrapping up our particular program, and we are wrapping up all our programs for today, but we'll come back again on Monday and we'll bring more programs from 8 o'clock till 5:30. The schedule is on your screen as well. You can see we'll begin from our Yogshakti program from 8 to 8:45, and the last program will be our Sahyog series from 5 to 5:30, and in between there will be a lot of programs for different subjects, for different classes, so you can watch them on different channels and also on our YouTube channel, that is NCERT official, and you can always write your questions in the live chat box too. Thank you so much once again. Have a great day ahead, and let me just tell you once again that there is the Pariksha Pe Charcha, which I am sure you must have seen. So this time it's the 9th edition of this program, Pariksha Pe Charcha. It's an initiative by our Honorable Prime Minister Shri Narendra Modi ji, and this particular edition is being organized for encouraging joyful learning and stress-free examination. If you want to know more about it, you can go to this website, innovateindia1.mygov.in, and we'll be repeating this information in our programs as well, so that you do not miss it. Thank you so much once again. Have a great day ahead. I am Tanvi Khurana and I'll take a leave of you. Namaskar.